Today, we're going to kind of shift gears from where we've been with equations and slope, and we're going to still kind of hang out there with the slope, but we're going to incorporate it into more visual representations, okay? So we're going to basically look more at the data part of it, how we represent that visually in a graph, okay? So let's look at our learning target to start off today so we kind of know where we're going with this. Today we're going to be constructing scatter plots based on collected data. What is our action word in that? Construct. So we're going to be constructing it. We're going to be building it and actually making our own data representation in a scatter plot specifically. Does anybody know, has that word scatter plot click anything with you? Have you heard it? Possibly there might be a little fuzzies. We're going to kind of clear that all up, and you're going to know exactly how to construct it by the end of class. And then we're also going to recognize patterns in scatter plots. What's the action word there? Level of mastery today, I want us to hit between 90% and 100% because I know that most of you have good prior knowledge on graphs. So this should be something that you kind of tie into something you already know, and it should kind of come to you pretty easy. Leading into why we learn this is kind of our starting point today. Now, I want you to stay in Nearpod, but I'm going to pull up a quick PowerPoint because we know that we're talking about graphs, right? And when was the first time you saw a graph? First kindergarten. Why do we have to know all this? You know, in all the math we've done this year so far, graphing is one of the most important life skills that we do. Okay? My why that I wrote is many jobs require employees to look at data with their company. For example, Walmart. How many and how much type of baby food do they need to order? The guy goes with his little scanner gun and he's determining, oh, this shelf's empty, and he's ordering that. He has to know how many to replace. How many did they use last month versus the month before? And he plugs it into his computer and it's going to set up some type of chart of data. Those jobs that require you to have a professional college degree? No. So it's something that everybody has to have a general knowledge about. And scatter plots is one of the ones that a lot of businesses and workplaces use. Because, you know, it kind of ties into graphing, right? You basically take your X line, so if it's, say, 10, and then you tie it to your Y line and you place a dot. Let's look at the visual representation. This is the scatter plot, okay? And you should see it on your screen. It's often helpful to represent the information in multiple ways to see the whole picture. Because immediately when I look at this, using prior knowledge, what do you notice about the dots? They're close together, but what else do you notice? They're going up. They are scattered, but don't they all kind of look like they're slowly creeping up to the top of the graph? Right, because look what's happening. The number is growing. Because as you work, the more you get paid. Does the scatter plot help us to determine whether or not the quantities are related? Yeah, because it quickly shows us that relationship. I would like for you to do some measured progress. On your desk is your chart up at the top. Put your learning target, and you're going to determine or recognize patterns in scatter plots at the top. Just make sure everybody should have one at their desk. And you're going to be assessing on the first learning target, which is to recognize patterns in scatter plots. And we're going to do 3 assessments on our Nearpod. So mastery would be a, how many right? 3. And partial mastery would be 2. And anything below, we just got to work a little bit more on it to get where we need to be. All right, give you a second to make sure you have that written down. Circle the 3 so that you know that that's your target for mastery. And let's look at the first one. Which of the following best describes the correlation in the scatter plot? And each of you on your desktop should have the problem. So look at the graph and then choose the best multiple choice answer. Look at our results. Everybody in the class chose letter A. So let's look at that example. And let's see, Jada, what did you notice about that graph that gave you letter A?
It was strong. It was tight together. So it was
What was tight together? The dots that were plotted.
And it's positive.
It's going up. It's given that more positive in the quadrant 1 location.
So it
all right, that on this one, everybody got it right, and we chose letter D as our final answer, and that's 100% correct. And we look at the solution, and you can kind of see that it appears if you take all of the dots and kind of look at them, they look like they're going where? Down. And that's good because on the last one it was the same thing with negative and a few of us got confused. So this was a good example for our third one. It does look negative, but the dots don't really look tight. So that would be considered what? Weak. It would be a weak negative. Okay, so you've had 3 questions. How many of you got all 3? Okay, that would be considered mastery. If you got 2 correct, almost there. And then anything below that, we're going to be working more on this week. And as we do exit tickets, you're going to see where you're going to pick up the things that we're still struggling with, okay? All right, so now what I want you to do is on your desk, there was a packet that I placed. And in that packet is our Learning Target guided notes. And it looks like this. Okay? And you can see our learning target is up there that you can construct a scatter plot. And below it is a website that if you do need to go home and check and kind of do like that flipped lesson and get some more extra practice, you can visit this website. I put it on there for you. And it's a lot of the same things that we just saw in the Nearpod. And below that is a sample from what we're going to be doing in class, okay? So if we're going to create a scatter plot, what is the first thing that we need to do? What we have to do? Label it and collect data. Well, I figured what we could do, and I know this from the science standpoint, I figured we could measure our heights to our arm span. Okay, if you know anything about basketball, this is a real big thing with basketball, how far. So as a group, what we're going to do, table by table, is we're going to measure our heights, and we're going to measure our arm spans, collect the data. Where do you think you're going to put the data collected? In the table. And that's why all the way to the other, so that's going to be what, about 29. So how would you figure out the total number of inches? 29 plus 36, very good. And then you're going to go ahead and do that for everybody on the team. Her hair is not part of her height. 29. Sorry, it didn't push it down much, you're good. It's like 27 and a half.
Wait, y'all show y'all cut my bush
30 to 36 because you have one ruler and then whatever you calculated for the other side. What was something that you noticed immediately about Marquesius's data?
Since I'm taller, my wingspan is gonna be long.
And I'm glancing at this data and I see that 59, that's kind of like an outlier. I could probably guess who that is in this class.
Jasmine.
Is that Jasmine?
Yes.
I thought the same thing too. Why?
Because she's smaller.
She's shorter than a lot of the people in our class. So do you think, before we even do the scatter plot, that there's a correlation? Think about Marquesius. She's the tallest in the class. What do you think her arm span's going to be? Longer. Now look at Jasmine, who's the shortest in the class. Look at her arm span. It's the shortest arm span. So there is that correlation just by looking at our data chart. Does anybody have any questions about that? Because I can walk around and check in with you and work with you independently if you're having trouble placing the dots. That's going to make a difference in your graph. What do you notice about the dots as you do it? They're very tight. Does that make sense?
Because we're all about the same height.
We're all about the same height. So it should be where they're really strong correlated. because y'all all about the same age, about the same height, right? And so your arm span should also be about the same. So that makes complete sense in our data. That's a reasonable math answer. What type of correlation is that?
A strong positive.
Strong positive. Why, Marquatius?
Because it's positive and it's tightly packed together.
It's positive and it's tightly packed together. What makes this a strong model? What are the things that we have in a scatter plot that makes it a strong model?
Your table.
Your table.
Your graph.
Your graph. Throw some things out.
Labels.
You have to have those labels, X and Y. What I would like for you to do independently is construct a scatter plot and then answer the reflection questions at the bottom. I'm going to be walking around assistant answering questions, so ask me if you're confused on anything, but I want you to independently construct one. There are also some other practices, if you finish early, within the packet that you can practice creating that scatter plot. Okay? I like the way Denzel, he's reading through the entire problem before he starts because he wants to make sure that he understands the actual data before he can construct that scatter plot. Kaylin went through and changed all of the Roman numerals. So did Jasmine into regular digits so that when she went to plot it, wouldn't be confusing. And don't forget to answer the reflection questions on the scatter plot at the bottom. Five. And then 35. Kaylin, go ahead and hand me your copy. I'm going to put it up for me, and I want you to share out. Let's look at Kaylin's. One thing I liked about Kaylin's as I was walking around was that she used a ruler to draw her line of best fit, which I wasn't really concerned with if you got that today because we're going to kind of build that concept as we move into scatter plots a little bit more. But we've talked about it before in pieces throughout the year. If you look at this, her dots are very neatly drawn, and she has her line of best fit where most of the dots. The line of best fit kind of helps us with correlation, doesn't it?
And tell you which way.
It kind of shows you, is that going to be a negative or is that going to be a positive? So that does help us kind of see that. Now, the last thing I want you to do today is I want you to reflect on what we've done, okay, by completing your exit ticket. There is an exit ticket, it says ticket out of the door, constructing scatter plots. And I have given you a scatter plot to show me what you've mastered today and some data that I want you to place onto the scatter plot. Once you are finished, I want you to place it into our exit ticket charts where you feel you are. Do you have it? Do you almost have it? Kind of? Or no? I need more practice. So think about when you tallied during our Nearpod activity and when you constructed the scatter plot a few minutes ago, and then the independent practice, how you feel about scatter plots while you're working this. Okay? Titles, scale. Good title. Get your scale. There is a reflection piece on the front of your guided notes where we practice with the height and the wingspan. Go ahead and reflect in that box about scatter plots today. What is hard? What is something that you still need to work on? What do you keep forgetting to do? Those kind of things from class in the reflection piece.